Have you ever wondered why it rains? Here's a simple demonstration that will explain this common weather phenomenon. Firstly, this is our setup, and as you can see, each element stands for a real-life factor. The water represents, well, water, which in real life could exist in the form of larger aquatic bodies such as the ocean or a lake. The water has been preheated to mimic the impact of the heating effects of the sun. The ice cubes mimic the cool air at higher altitudes that causes water vapor to condense into droplets. The bottom of the tray, as well as the sides of the container, constitute the solids water vapor glom to in order to condense. To start off, the heat from the sun causes the water from the surface of the earth to evaporate into a gas, or water vapor. As water vapor increases in height, they cool down and condense into small water droplets. This is because temperature decreases with height, and since cooler air is less energized, water molecules can more easily condense. When eventually the rising air reaches a point where it is 100% saturated, in other words, cannot hold any more water, it is called a dew point. And it is above this point that condensation occurs. If this looks familiar, it might be because dew, hence dew point, usually found on grass or a car window, is also just condensed water vapor. Clouds form by having water vapor condense on small solid particles like dust, sea salt, pollution, or other droplets of water. In our case, they collect on the tray and the sides of the container. In the cloud, as more vapor condense onto other water droplets, the droplets grow. When they get too heavy to stay suspended in the cloud, even when updrafts was in the cloud, gravity causes them to fall down to Earth's surface. And as you can see right now in the demonstration, it's raining in the container. Though of course, that was just a simplification of the phenomenon for the sake of clear presentation. For instance, on a broader scale in real life, we experience various types of precipitation. For example here, when the air in the cloud is below the freezing point, ice crystals form. And from that, if the air all the way down to the ground is also freezing or below, you get snow. However, as the layers of atmosphere within the cloud and between the cloud and the ground differ in temperature, you get other kinds of precipitation, such as hail, rain, sleet, and so on. Rainfall is simply precipitation in the liquid form, and it has been classified into three main types based on the origin. They are convectional rainfall, orographic rainfall, and cyclonic rainfall. So, whilst my demonstration explains the basic science behind rainfall, these are the ways in which the process actually takes place in real life. Convectional rainfall is when the air, upon getting heated, becomes light and rises in convection currents. As the air rises, it drops in temperature and condenses. Convective rain and light precipitation are the result of convective clouds, such as cumulus clouds and cumulonimbus clouds. In the initial stages of this precipitation, it generally falls as showers with rapidly changing intensity. Orographic rainfall occurs when moisture-laden air is forced to rise above high ground. As the air rises, it cools and the water vapor condenses to form clouds, then rain, which then falls on the windward side. The other side of the high ground, known as the leeward side, receives very little rain. Cyclonic or frontal rainfall occurs when a warm front meets a cold front. The dense cold air sinks to the ground and the warm air rises above it. When the warm air rises, it cools. It then undergoes condensation and precipitation, as per usual. This type of rainfall usually brings about heavy rain. And that would be all. So to recap, today we demonstrated how evaporation, condensation, and precipitation leads to rain, introduced different precipitation types, and briefed the 3 main types of rainfall. Thanks for watching and see you next time.